Okay, guys. Now we understood the first part. Now, what is the agenda is very, very clear, right? Now, the second part is we're going to go a little bit deep dive in this concept called as IoT. Because, see, in this particular webinar that you've chosen, right, you have to see, we can always discuss about all the topics, but you have specifically chosen IoT and data science or the data science application inside IoT, right? Or by separately by itself. So, we will touch base in IoT and in data science. What is that we're going to touch base is very simple. Hey, look, how is the industry fast forward moved in terms of its application and technologies? Let's start with IoT. Okay. See, first of all, guys, I'm not going to explain, IoT as though I'm going to explain it to a very, very advanced person. I'm going to explain this as though I'm explaining to a kid. So what is basically IoT? If you look at the fundamental principle, right, there is a thing that a sensor, basically something that collects, let's say, data, responses, etc. It processes into meaningful information. It stores it typically in a cloud, and then users get to interact it through devices, through apps, etc., etc. So this is fundamentally IoT all about. Okay. Now, why am I going to the kid level and explaining stuff from the scratches? See, that's a problem, guys. We're learning some very advanced nanoscience. We're learning something in space technology. We're learning this, that, etc., etc. But the problem is we fail to understand where is it we're going to apply. So what I'm going to do is I'm going to start from the very, very basic level, from the scratch level, kindergarten level of IoT, right? Take it to the very, very advanced level. Okay, that's how we're going to go through this entire process. Okay, so what is that, right? If you understand some of the everyday applications, from very basic things to very advanced things, for example, in defense, predominantly IoT has very strong applications, right? At the same time, it's used in everyday appliances like your washing machine, your phones, your air conditions, even your devices, lights, bulbs, etc. Everything is talking with you today. It's connected with one thing or the other. For example, look at this. I'm wearing a smartwatch, right? So this watch is basically connected to my app. You guys know this. I don't have to really teach you. And agriculture, right? Some of the areas where you would not have been expected, it has application. So that is a point, guys. The first advice that I usually tell my students, you might be from an electronic student, okay? Some students come and ask me, Hemant, can you actually show me a triple company? Tell me some list of VLSI companies. Hey, there are VLSI companies like Xilinx, etc., etc. But it doesn't mean that only VLSI engineers can be hired there or EC engineers can be hired there. So there are cross-functional areas where you can always apply. See, defense is very much related to mechanical, those kind of places, right? But still, an IoT has application there. Agriculture is not even there in engineering, but massive application there, right? So very advanced things, guys. For example, I can go to the extent of talking about healthcare, one of the very, very predominant areas. You guys didn't study biotech, you're not studying biology, etc. But still, healthcare is a very important area of application for you. Supply chain, logistics is very, very useful. Mechanical guys can always make the best use of it. So stop asking me questions like, Heyman, show me a mechanical company so that I can get hired there. Show me a civil company, show me a triple E company, etc. There's no such companies like that. Okay. So logistics is a very important area. Mechanical engineers are eligible to learn that, right? Triple E, guys, smart grid. Again, you ask more about triple E, no. So there is an application area in your domain as well. Now let me talk about a very niche IoT application area. Okay, something I'm going to talk about, IoT enabled cars. Right. The best example I can give you is Tesla. Now, what is it? Why is a Tesla very, very different from a regular car? You guys know the basic information, but I'll tell you how it is very much correlated with what you're actually working on projects and learning in IoT. Okay. For example, what was Tesla able to do, right? They have a inbuilt Bluetooth capabilities, opening the car garage door, etc. Right. At the same time, they were able to do a simple software update and fix 29,000 cars seamlessly over the air, guys. They didn't invite all the 29,000 cars to a let's say a workshop or something like that, or a service station, and they have to kind of, what do you say, basically repair all these things. They're able to do it very, very remotely. Now, one very interesting application, IoT, I really like that. I was even stumbled upon the fact that does IoT have such levels of applications? Okay, that's where the interesting part comes. So what did Tesla do was, way back in 2017, right? There's a very famous hurricane called as Irma. So typically hurricanes come from the East Coast, your Washington, New York, you come a little bit down the line and Texas and all these areas, right? So a little bit towards the north. So hurricanes are very, very predominant there. And a lot of people live in that area of population, the coastal areas, because Central America is full of desert and all this place, right? So a lot of Tesla users there, right? So what did Tesla do was, first of all, it was able to predict the hurricane data, because data today is available for free at US. You can download the data from NASA, whatever you want. Based on this data, what Tesla was able to do as a call was, with the help of IoT device, right? Because the entire car is being connected to their centralized database, to the cloud, right? They were able to temporarily change a simple setting on how the batteries were consumed. You drop it on your phone, you'll have a battery saving option. You can click on off. If you click that on, your battery will last for a longer time. If you click that off, your phone will perform much longer, but the battery will dry out sooner. So in a similar manner, the same thing, it is able to do to the car. And you know that Tesla completely operates on electrical power, right? There's no fuel power, right? So it was able to temporarily change its setting remotely. Of course, with the help and the consent of the users. It's not that they did something uncontrolled. So what are the point was, as an outcome of this, right, customers are able to get to safety without needing to recharge their batteries frequently. This was only possible simply because IoT was there present in Tesla. So what happens? Just imagine this: if there is a hurricane, right? If your car is running on a normal mode, you need to frequently find charging stations. So whenever there's a hurricane hit, charging stations might take a hit, service stations might take a hit, infrastructure might take a hit, and you are running in a car, right? Battery is getting consumed faster. You want to charge, nothing is available. You get stuck there. Then you need to tow your car to the service station, charge your car, see is there any problem with it, is it hit, etc., etc. But since this was applied, right, all the users were able to get back to safety. That is very, very important. Okay. And that is one important point. They're able to get to safety. So, okay, now this is not just beneficial for the user, guys. Let's understand how IoT enabled vehicle, okay, how an IoT enabled car is beneficial both for the user as well as for the manufacturer. Okay, for example, let's take with the IoT, right? So what happened was every user was able to save 12 lakh rupees per owner. Okay, per owner, they were able to save 12 lakh rupees. Why? Just imagine this. Your car is running fine. It is running on optimized mode and a hurricane is coming. You're safe parked inside the house. You don't have to frequently search for charging stations. You don't need to take your car to the garage or the service station to service your car. So cumulatively, right, for these many number of owners, 12 lakh rupees was saved. I'm converting it to Indian rupees because things in US is very expensive. Okay, but still 12 lakhs means a lot to them basically. And most importantly, not only the user is getting benefited from the same, even Tesla as a company is getting benefited from the same. How? Very simple, guys. If all these thousands of cars will need to come to the service station and charge, right? There's a lot of man hours required. They can only receive these many number of cars, a lot of coordination, work, stress, etc., etc. So cumulatively, since this car did not even come to the service station and they're able to find the solution by themselves, 3,000 man hours of labor and service repairs were avoided by the company. So it's a win-win situation for the user as well as for the car owner. Okay, I mean, so the user as well as for the company manufacturer, something like that. Now, one very interesting area of IoT is in the healthcare sector. Okay, this is a very relevant disease to sort of corona, but not in the exact mean. In the European regions, right, there's a lung disease that is going on by the name COPD. The Indian version of it is called as the asthma, the breathing difficulties, etc. The treatment and the diagnosis of this particular disease was very expensive because there's a thing called as spirometers. Okay, it is only available in hospital, expensive equipment, very difficult to obtain, etc. So what did a group of IoT engineers do? What they wanted to solve this problem. They wanted to find an alternative where these tests and diagnosis can be done easily because this disease is also spreading among a lot of elderly population. So what they did was they just did a simple thing. Abundant network sensors, right? They were simply using the microphones in the mobile phone, okay, to create a small network. So what did they do was very simple. They developed an interesting algorithm, okay, which measures the lung health by analyzing the sound, okay, by just blowing on the phone's microphone. Your phone has a microphone, no, through which you speak. There's somebody able to hear, right? All you need to do is very simple. The COPD patient needs to pick up the phone, okay, call a simple toll-free number and just blow. Oof, that's all, guys. Okay, based on the blow, the intensity of it, etc., right? There are complex network computation that happens in the backend. That's where the IoT comes in the picture, and the test results are able to show it to the hospital. Oh, right. Now, by delivering this, right, the particular system of diagnosing, etc., toll-free number, etc., was able to develop a 95% accuracy and therefore saving thousands and thousands of dollars. Why? See, a spirometer is a very expensive device, A, and the hospital needs to host that device. They need a floor space. So once they have the device, patients need to start coming in. They need to receive the patients. You need doctors, you need nurses, caretakers, guys, etc., all these things. There's a cost to this, and the patient also needs to travel to the hospital, spending his time, cost, resource, money, etc. So both these aspects are saved. Both these aspects were saved, right? So 95% accuracy, guys. See, this diagnosis is not a very severe diagnosis like corona. Even there is an inaccuracy, you can always drop down. But 95% of the people were saved from kind of coming to the hospital frequently. Again, if you look at this, right, how this functions, right, there is a database which collects the information. There is a real-time upload, and there is an app for communication between the user and the hospital, and all the data are classified, and 3,800 patients were admitted under this particular scheme. Now, the other thing which I want to tell you here is, you can look at this, right? There is a lot of classified data because patient's name, details, the health factors, etc., everything is mentioned there. So that's where a cybersecurity expert also comes into the picture. This is why I told you guys, stop tagging yourselves as a computer science engineer, electronics communication department engineer, triple E engineer, instrumentation engineer, this engineer, that engineer. No. Eventually, you're engineers with a skill that is cross-functional. So even a computer science guy has a very interesting domain to work here. He can work in cybersecurity, right? An electronic guy can always work here. A triple E guy can always work here. Instrumentation guy can always work here. Mechanical guy can work there because pyrometers is something that's related to you. Biomedical guy can work there, right? So that's a very important point. So if you understand, again, if you weigh the cost to benefit, right? First of all, the users. For a simple test where you need to blow and some signal need to be captured, you don't need to essentially visit the hospital. Pick up your phone, do a simple call and blow. Your test is done. So you save a lot of time and money across multiple users. It's $1 million for all the users to put together, right? Thousands of dollars are saved. At the same time, right, the hospital. See, it requires, see, what happens is if there's a hospital, if it can cater to, let's say, 1,000 people, they need to buy one spirometer. Okay, maximum 1,000 itself is too much. Let's say in a day, 50 people it can cater. Okay, now if 100 people are coming in a day, the hospital needs to acquire one more spirometer. Now, what is happening is with one spirometer, the hospital is able to diagnose millions of patients because all the data can be received. The test can be run in batches inside the spirometer and the results can be outputted. So it's a win-win situation both for the user as well as for the hospital as well. Okay, so that's a point, guys. See, that's why I repeatedly tell you, don't stop classifying yourself as a department engineer. You're not that. Let me be very, very frank. Okay, see, let's look at the same IOPD, the COPD device, right? The IoT application is same. EC guys always has an application in terms of developing the devices, the network behind the phone call. I mean, the let's say, for example, the blow signal is coming right in a phonic sound. It needs to be processed and changed with the particular frequency and intensity. Therefore, hardware devices are required for that. So you guys have an application there. Computer science guy, a lot of data involved in this process, to and fro, a lot of data involved in this process. So you guys involved in cyber security, all these aspects, database, cloud, any IoT device, the data has to be stored in a cloud. Cloud computing, who is the guy who does it? The computer science guy. You have application in this domain. Mechanical guys, we talked about the spirometer example. You are the ones who take care of assembling the device. You ensure that multiple inputs come at the time, the optimization, etc. AAA guys, you take care of the, for example, you have actual applications in power handling and management. Okay, because today Siemens, right, Siemens has stopped calling itself as an electrical company. I want you to change this term, guys. Please don't call yourself as a triple E engineer. Okay, you always have cross-functional applications. Siemens expects you to have lot of such skills. IoT has been very, very interesting application there. Now, so if you understand, right, what are the skill sets that are required? Okay, for you to get into an IoT domain, right? There are different things. For example, there's a data analytics. See, that's the other thing. Again, I want to tell you, please stop classifying yourself as an electronics engineer and a computer engineer. If you understand what is the skill requirement for IoT, it is data analytics and big data. Computer science guy, you can work in product companies, no doubt about the same. Okay, you can work in tech companies just doing the data stuff. At the same time, even manufacturing company always hires a CS guys. A Bosch will always hire a CS guy, right? Even an Ashok Leyland could hire a CS guy because it has a lot of electronic equipment. Tesla has been massively hiring CS engineers, ML engineers, NLP engineers, etc., because there's a voice command, this and that. So if you look at the skill requirement itself, right, data science and data analytics and big data has been a strong requirement of skill. Now, EC guys, you never thought you have application here, you have application. I mean, sorry, computer science guy. EC guy, you thought data science is a computer science subject. No, you actually have an application if you want to pick that up in IoT. Right? Similarly, cyber security or IT security, embedded software development, embedded electronics, cloud development, computer science guy, automation, instrumentation guy, mechanical guy, AI, computer science guy, robotics, mechanical guy. Everybody needs to come into this picture, guys. So that's what we mean by cross-functional. Okay. Now let's understand a little bit niche level understand. First, if you understand what are the practical skills that you require in terms of programming languages. Typically, the embedded systems that run behind all these IoT devices, C programming that has been regularly followed. Embedded C, there's something that's a little bit more advanced, specific to C embedded systems. Python, that's something in predominantly used, and Java has been used. So these are the basic things, right? For example, there are also niche programming. So what do you mean by niche programming is that, let's take Raspberry Pi. They have their own set of programs. Okay, more or less similar to C, embedded C, all these things, but they have their own set of programming, their own syntaxes, their own commands, etc. Arduino has its own set of programming, etc. So the point is, right, first of all, you guys are only learning what's taught in a syllabus book. And please don't come and tell me, as I already told you, right, I have an online course in Python, I have an online course in Java, I have an online course in Arduino program. I wanted to show a practical skill. You're able to code in that particular interview and get the result. I told you an example of that Byju's interview, why 98% of the people are not even able to crack the interview. That should not happen to you. So this is the fundamentals. You guys know this. When I say know this, don't come and tell me I have a 5th semester CGPA mark sheet in Python. I have an online course certificate in Python. That's not going to help you get a job in IoT or data science. No. Okay, next thing, you require hardware skills. Hardware skills are a little bit essential, guys. Okay, for example, your when you talk about databases, right? It's typically stored in Google Cloud or AWS. That's depends predominantly. It's AWS, Google Cloud, and Microsoft Azure depends on the devices and the system design. Okay, now this is a cloud, as we already discussed, right? There is a hardware, there is a software, there is a database, and there is an interface. That's your device or something, right? So the software typically includes the ones that we just saw. The hardwares include Arduino and Raspberry Pi, something that is very, very advanced and data friendly, etc. And the cloud, where the database is stored, includes your AWS, Microsoft Azure, etc. Okay, now this is the outcome. You actually need to show a project. Okay, for example, students on a platform, right? They get to work on something called as a smart building using IoT. There is no switch, completely voice command and app control. The switch, the light in the building operates. The home automation system, you're able to switch on your heater, switch off your heater, you're able to switch on the electric cooker and switch off the electric cooker, different appliances, different devices like washing machine, etc. You throw things, it'll take care, etc. Completely automated. Okay. Now, if you look at internships, this is what important is. So when you talk about developing skills in IoT, right? I repeatedly, like a parrot, I'll keep telling this. Don't show me a CGPA certificate. Don't show me an online course certificate. You actually need to have hands-on skills. What do you mean by hands-on skills is that when you sit for an interview, if a programming is given, you're able to solve the programming. How does a recruiter even believe you and call you for the interview? That's when you need to show an internship experience, or you need to show an project exposure, or you need to show something that you have application upon, some industry project that you have application. And that's something that internship really, really strongly helps you. Okay, internships are offered by big guys at the same, even small companies to recruit them. Right. Now, the next interesting topic is data science. Now, don't think that data science is a computer science department subject or a computer science department company, and IoT is an electronics communication company. These are all always interlinked. I'll tell you how data science works is with respect to IoT, right? For example, let's take the same IoT, right? There is a data discovery. You collect some bunch of data. It is prepared inside the system, right, in a proper rows, columns, classifications, syntaxes, conditions, etc., etc. There are models that are built through which these data are passed, right? That's where your interface comes, right? For example, the intensity of, let's say, a bright light, brightness of light, or let's say the temperature at which the cooker should cook, or the speed at which the washing machine should operate, etc., etc. So you build models where these data go through and they give you a meaningful information, which is then communicated with you, and you control the device based on whatever data is generated. So this is how data science cycle looks like. So data science can be generally applied elsewhere also. That application also will discuss, but also we'll discuss with specific to IoT how it has application. For example, right? Again, if you understand what are the top skills that are required, right? With respect to data science, Python and R are the very clear winners. SQL is something different, and you have something called a SAP as well. Okay, you have big data tools like Spark, Hadoop, etc., etc. There are different tools, guys, basically. But R Python has been predominantly used. Okay, everything has its advantage and disadvantage. That's a different ball game. Okay, but R and Python has been predominantly used. So if you understand the skills that are required for you to become a data scientist, either in the IoT domain or generally, one, you must understand core statistics. Your mathematical modeling should be very, very strong. R and Python depends upon which kind of niche you want to get into, right? Machine learning algorithms, right? Data visualization tools, like you have tools like Tableau, you have tools like Google Studio, you have different tools like Power BI, etc. And you need to understand a little bit of databases, AWS, little bit programming touch bases there, and basic communication business skills. So these are the fundamental skills, the soft skills and the hard skills that are required. Similarly, right, you understand in terms of statistics, what are the skills that you should acquire? One, there is in descriptive statistics. Second one is in inferential statistics. Descriptive statistics is like, let's take a height as a concept. Now, what is descriptive is that you classify some people under maximum height, some people under average height, some people under minimum height. What is inferential is that you get, based on the height, you're able to tell him whether he's tall, average, or short. So that's the difference between descriptive and inferential. So these are fundamental skills you need to learn. So when you take this framework, right, you apply this across any data point, you will still be able to understand what is the difference between descriptive and inferential. Okay, these are fundamental skills. Similarly, right, you take the difference between R and Python. Now, what is the difference, right? R is more of a statistical language, whereas Python is used for a general. What do you mean by that is, R is most probably used in the computational state, for example, for descriptive purposes, etc. Whereas Python is also used for that and for other purposes. So Python has a little bit edge on the same. And most importantly, right, R is always about better data visualization. Why? Because when you feed the data, R typically comes in the later stage of the data cycle. Remember this data cycle we saw, right? Hey, you know what? I'm building models. I'm getting into actions and communication. So R is a very strong application area in this particular area, in more of the visualization parts and the computation parts. whereas Python is typically used in the deep learning side of it. So it takes a little bit in the earlier stage. For example, you prepare and clean the data, you build the mathematical models. So of course, everything has an end-to-end application, but the strength of a particular language lies in certain areas. See, when you become a data scientist, right, it's not that you're going to do everything. You'll always be only the data discovery stage. You might only be in the preparation stage, or you might just build models, or you might be the guy who's communicating to the client. So as per that, you kind of learn the skills that is required for you. Okay, and most importantly, right, you understand capabilities. It has different packages, right? Whereas Python is more of open source, so it is still kind of evolving there. R is more of a embedded in a programming language. Everything was given there basically, and generally the function is that R is a little bit slower when it comes to performing huge computations. Python is very faster, and in terms of popularity, R is less used and Python is more used. Okay, and again, if you understand that there are different clustering algorithms, okay, for machine learning, right, these algorithms are very important for you to learn. Okay, for example, when you pick up data science, especially in IoT, right, you need to understand these techniques. That's why I told you, right, you are not an electronics communication engineer. Please stop tagging yourself like that. You require certain skills that are required for the job. Please focus on that. Don't have this department things. I belong to a department. Show me AAA company. Don't ask questions like that. So the point is, right, there are different points, different algorithms that are used. For example, the k-means clustering, one of the famous ones that are used, naive Bayes, etc., etc. So these are different algorithm techniques. And again, guys, whenever you show this, right, please don't come and tell me I have a 6-semester paper mark sheet on this. I have an online course certificate. No. Have you used k-means clustering in one of the projects? As an outcome of that, were you able to show that project has actual application in the industry? Actual application in the industry has created a small impact in the industry. Are you able to show all these things? Okay, again, if you look at all these techniques, right, you cannot master all the techniques. Techniques are always classified based on supervised, unsupervised, supervised, unsupervised, and the reinforcement learning. So certain kind of techniques, right, come under the unsupervised learning, where the techniques run by itself, it's independent, etc. So the details and all we look into it later, right? And again, if you look at it, right, in terms of visualization, as I already mentioned, right, R is a language which is very strong in terms of the data visualization. Whereas Python, right, you have syntax, you have libraries what you can use for basically for visualization. So you feed the data, you use this particular library, the output gets generated automatically. You can kind of generate it using an IP address or something. Whereas R has its inbuilt data visualization tool, right? So for example, it can be I've used R extensively. I specialize in my analytics and MBA, right? So let's say I use some of the functions like lattice or a leaflet or a color burst or sunburst, something like that, right? I feed the data, the output will come here. You can download as a GIF and put it on a presentation. That's simple, guys. Whereas Python is a little bit more complicated. Getting it embedded on communication part becomes a little bit trouble, right? So that's a point, guys. See, the other point is that, right, and let's actually understand a case study. I've been talking a little bit theoretical in terms of the skills required, etc. Let's actually understand a case study. This was one of my former students who basically studied with us, etc. He did his masters in Carnegie Mellon University. He's working at Microsoft in the US. So this guy did a very interesting project, and one of his colleagues are doing this project. What this project was? This case study was taken from that. Okay, so Microsoft wanted to determine how does a face-to-face interaction among the staff could boost an employment performance and save money. Okay. See, right now it's a lockdown. Everybody's at the house working from home. It's always a big trouble to coordinate meetings, etc. But companies are desperately wanting their employees. For example, IBM has leased millions of square feet of offices spaces in Bangalore. So companies desperately want people to come back to their office and work. So one very interesting project application in this particular domain was Microsoft developed a project. This was before lockdown, basically. They did this. So what they did was they wanted to kind of develop an algorithm. The output of the algorithm is it could boost an employee performance so that the company can save money. Because the employee do 10 work units in 1 hour, 20 work units in 1 hour. The 20 work unit is more efficient for the company, right? So what did it do was, it was kind of moving some 1,200 people from a 5-building block to a 4-building block. So these guys were there in a particular place. From a 5-building block, they were moved to a 4-building block. So they use different analytic techniques. For example, right, they used to have these cards. So I have this student used to tell me, even if I have to go to the restroom, I need to swipe the card. So if I have to go to the pantry, I need to swipe a card. If I need to go to, let's say, a meeting room, what meeting is this about? Whether I am a part of the meeting, everything is kind of embedded in their card, their RFID tag. So before you swipe in, right, every data is being captured in terms of what you're doing inside the company. Microsoft did this very interesting experiment without even the employees knowing it. Okay. The point is, right, the heavy data science applications are running behind the background in terms of how they collect the data, what duration they do it, etc. Very heavy analytics was used, very heavy techniques were used, data science techniques. Now, what is the output? They did all these things, right? They were able to save combined 100 man hours per week. across all the reallocated staff members. This estimated a total saving of 520,000 US dollars in a year of employee time. So what happens is, but I'll tell you what Microsoft did by using this also. Okay, they kind of gave improved statistics to their managers. Hey, you know what? Over a period of week, you're wasting so much time in a meeting room. Therefore, you could have all these meetings in a Zoom call or in a Teams meeting itself. You don't essentially need to come and meet physically. So the manager is really able to implement that and increase the efficiency. Likewise, this process was going on continuously. Okay, so if you look at this data science funnel, right, you'll understand this application in real time. Let me show you the funnel. 1 second, guys. This particular thing. If you understand this, right, so what is happening here is the Microsoft is collecting the data, they're preparing the data, they're building models around the same, they're giving the insights to the managers, and they're communicating, and they are implementing, and again the process of data is being collected to improve the process. So this is like an infinite loop. It keeps running until the process, until like infinitely all the employees work to very, very efficiently. But at least, right, just imagine this, by doing this, they were able to save 520,000 US dollars just for one building with 1,200 employees. Now, Microsoft have thousands and thousands of employees, very, very big office spaces. And just imagine if Microsoft could sell this technologies to different companies like Apple, Oracle, IBM, Intel, etc., how much money is saved there? How much money goes into the challenge there? 520,000 US dollars, it's like 3.2 crores or 3 crores of Indian rupees is saved by just a small algorithm. But the complexity in the algorithm is very much. That's the reason data science are getting paid in such huge numbers, guys. Okay, so that's a question. That's a question that I really want to leave you open with. What is the question is, your college curriculum. Let's understand this. Your college curriculum is like an old telephone booth. I'm not even sure whether you guys have seen this telephone. Okay, well, I was a kid. I used to be in my dad's office, right, in business. So they used to have this phone dialing very, very strongly. Apart from calling, nothing you can do with that. You can receive calls, you can make calls. But today, you guys know what is the level of smartphone application. You guys know to use smartphone much better than me or any of my senior people, because you guys are glued to this all the time, and you guys know how much advanced it is. See, one thing in terms of usage itself, you guys know how advanced it is. At the same time, much more than you have imagined of, right? Smartphones are very much advanced. But the problem is the industry has been running in such technologies. Your college books, your college 8th semester projects, the college exposure. I've been learning something in college like an old telephone booth. So that's a question. See, that is a question that you guys will face when you actually have to crack an interview in IoT or data science. Where do you have such exposure? How can I get a job in my core domain? What are the specific skills? See, whatever I've told you is a niche. That's not exactly as per the job domains. Okay, and most importantly, what do I need to do overall? That's a question which I want to leave you open with. How do I adapt yourself? How do you adapt yourself so that these changes and all the hands-on skill that you require, you can build it over a period of time? So what I'm going to ask you is very simple. Next 5 minutes, me and my colleague Nitin will collectively tell you how is that you guys can go about these changes. What are the do's and don'ts, this points, that point, etc., etc. you need to do. Okay, if you get that knowledge, trust me, guys, all these interviews are going to be like a cakewalk for you. So that's my question. Are you interested? Next 5 minutes, do you really want me to continue? Or do you think, Hemant, it's very, very boring, Hemant? You want me to quickly wind up? What's your choice? Quickly tell me, guys. Yes or no? You want me to continue? Yes or no? You'll get some automated responses. Please ignore that. Okay, Nitin, I will just transfer the screen to you, Nitin. I think you can hear me as well. I'll just transfer the screen. I'm switching off my video on screen. I'll just transfer it to you. Just a minute, guys. You'll just see a small change of screen.